Hello again. This is the second video for section 3.3 for calculus. In the first one we talked about the idea of what average rate of change is and what the idea of an instantaneous rate of change is and what we're looking at. Average rate of change, it's just the slope between 2 points. That's all you're doing, change in y's over the change in x. The instantaneous rate of change is a limit, but it's the limit of that slope as the difference of the x values goes towards 0. So those 2 points that you found the average rate of change with, you're bringing those 2 points very, very close together, so essentially it's 1 point, but you're finding the slope of that line. So looking at this example, you have the distance in feet of an object from a starting point given by this equation. X is the time in seconds. So the first question is find the average velocity of the object from 2 seconds to 4 seconds. So average rate of change. What we are looking at is just the slope between these 2 points. So we have function s, that's the distance in feet. So what we're going to do is s of 4, that y value, minus s of 2, the other y value, divided by the change in time. So it's a change in position divided by the change in time. That's what velocity is. It's just how far you go over a certain amount of time. So s of 4, when you plug in 4 into this function, you're going to get 52 minus s of 2. When you plug in 2 into this function, you're going to get 38 all over the change in the time. So 52 minus 38 is 14 over 2, which is 7. Now, the distance was in feet, so we did 14 feet in 2 seconds, so this is feet per second. That is the average velocity from 2 seconds to 4 seconds. Now, the next part of the question is find the instantaneous velocity. That is a limit. As h approaches 0, what we are looking at is this equation right here. We're taking the limit at a certain x value, so what we're going to do is plug in 4 for A, for our problem. It's the instantaneous velocity at 4 seconds. So we're going to do s of 4 plus h minus s of 4. So it's 2 separate y values. And then we're taking the difference in those y values and dividing it by the difference in the x values. So 4 plus h is one x value minus 4. That's where that h is coming from. All right, so when we plug in 4 plus h into this equation, we are going to get 2 times 4 plus h squared minus 5 times 4 plus h plus 40. And then we are subtracting s of 4. Now, we figured out what s of 4 was in part A. That was 52. So we don't need to redo the calculation. We already know it. That is all being divided by h. And I always forget to write it, but we still got that limit sitting out in front as h approaches 0. All right, so we need to clean some of this up. Let me move the page up here. So, order of operations. 4 plus h, when you square that, let me write the limit again, as h approaches 0. 4 plus h, quantity squared, is going to be 16 plus 8h plus h squared minus 20 minus 5h. We got a plus 40 minus 52, so that becomes a minus 12 all over h. All right, going to do some distributive property. Move this page up again. Still haven't taken the limit, so it's still sitting out in front. We got 32 plus 16h plus 2h squared. We got this minus 20 and a minus 12, so it becomes a minus 32 minus 5h. All of this is over h. We have a couple of like terms. 32 minus 32 goes away. 16h minus 5h, we are looking at an 11h plus 2h squared all over h. If we plugged in 0 for h, we're still getting 0 over 0. So now let's divide each of those terms. by h. So we got 11h over h, which is 11 plus 2h. Okay, now that we've simplified the limit as h approaches 0. As h approaches 0, that term goes to 0. We are looking at 11. So at 4 seconds, go back to the initial problem, find the instantaneous velocity at 4 seconds. This object was doing 11, and these were in feet per second. Okay. Between 2 and 4 seconds, it was doing an average of 7 feet per second. At 4 seconds, it was going 11 feet per second. That's what we're talking about with instantaneous. So there's a little bit of algebra, there's cleaning up to do, combining like terms, being very careful of the negatives, all this algebra stuff that we've been working on so far this year and things we've been working on for the last several years. It's all coming into play, it all becomes very important. So when you're doing these problems, you got to take your time, plug in the right things, follow your order of operations, be careful with all your numbers. All right, the last thing is just a definition. Okay, I've talked about this before. This term, marginal, whether it's marginal cost, marginal profit, marginal revenue. Once you see that term, we're talking about an instantaneous rate of change. So if it was marginal cost, it would be the instantaneous rate of change of cost. So how much is it costing to produce this extra item? If you're making 30 items, what's the cost to make 31st item? All right, so it's an instantaneous rate of change for whatever the item is, cost, profit, revenue. So you do the same type of problem. You'd have a function, you'd do the limit as h approaches 0 of the difference in y's over the difference in x's. All right, that is it for this video. Hope it helps you. Ask questions when you have them.